Chapter 3.4 Fundamental Theorem of Algebra. Okay, there are some theorems and definitions. Okay, first of all, let's say P is a polynomial function of degree n that is greater than 1. Now, with the complex coefficients, then P of x has at least one complex zero. What do you mean by this? Okay, complex numbers is composed of a, the real part, and imaginary part, right? This is the real part, and BI is the imaginary part. All right. And then complex numbers is composed of two parts. So that one contains real numbers and imaginary numbers, right? So real numbers is a subset of complex numbers. So when you say complex numbers, then it may contain real numbers. Also, the complex number also may contain the imaginary part as well. Okay, so imaginary part. Imaginary numbers. So together. So when we combine this together, that is called complex number. All right. So if a polynomial function contains complex coefficients, so for example, like 1 plus 3i. So if there is I, something like that, then there is at least one complex zero, or it can be a real number as well. Then there's a complex zero. Okay, complex zero means once you plug in, once you set the polynomial equals 0, then there are x values, right? There's at least one complex zero. That means it can be a real number, or it can be also real part plus the imaginary part. All right, so there's at least one. And at most, there are n. Okay, as you see, this is the number of zeros of the polynomial function. Still the same thing, same meaning. So P of x, the polynomial, has exactly n complex solutions. This is really important. Exactly n complex solutions. So there is at least one complex zero. Why there's exactly n complex solutions? If the degree is n, then there are exactly n complex solutions. That means it includes the imaginary unit also. So the solution x can be a real number like this, or can be something like this, 1 plus 2, something like this, or it may contain 1 plus or minus something, right? Or x may be 2 plus minus 3i, something like this. So real part, imaginary part. Altogether, it is a complex number. So including these complex numbers, the imaginary unit as well, there are exactly n zeros. Okay, so that is the number of zeros of polynomial function. So if there's no complex zeros, then maybe there are n real numbers, real solutions. If there are complex solutions like this, then the complex solution is what? Plus or minus. So there are two of them, right? So if there are, let's say degree n is, let's say 10, then there may be 10 real solutions, or subtract 2 if there are complex solutions, then you may subtract 2 from this number, so 8. So subtract another 2, then there may be 6 real solutions, 4 real solutions, 2 or 0 real solutions, depending on the number of complex solutions. The theorem is really simple. So let's say C is a solution. Then x minus c will be a factor, right? This will be a factor of P of x. Make sense? We did this one last time. So if c is a solution, then we can write it a factor x minus c times, and then the rest, the quotient, right? When you divide P of x by x minus c, then let's say Q of x is the quotient. So P of x will be a product of x minus c and q of x. And then the degree of the q of x is 1 less than the degree of polynomial because we divided it by x minus c. Can you see? So the degree is 1 less than the degree of P of x. All right, so linear factor theorem means let's say there are exactly n complex solutions, right? Complex zeros. So if you make it a factor, then it will be x minus c1, c2, and so on. So let's say c1, c2, and cn are complex solutions. Complex numbers can be real number only, or it may include the imaginary part. So there are exactly n complex solutions. So there are exactly n factors, and that factors can be a binomial, which is linear factors, right? So can you see it? So x equals c1, x equals c2, x equals c3, x is cn, right? There are n solutions, complex solutions. So from this one, you can write it x minus c1 as a one factor, and x minus c2 is another factor. Keep going. Then you have x minus cn as one factor. So product of all these factors, okay, these are the linear factors, are linear because x plus minus something. So this is a linear factor, right? So there are exactly n linear factors. So the leading coefficient is an. So it's got to be starting with an and multiply by n linear factors. Can you see this one? Okay, this is just a definition, and this is a very simple definition. Okay, make sure that P of x, the polynomial, is a degree n plus something, right? Then there are exactly n solutions. Actually, there are n. Okay, there are n complex solutions. This means complex zeros. Complex zeros means it may be a real numbers, or it can be a real number plus the imaginary parts, right? Imaginary parts. So something like 3 plus 2i, like this. Plus minus, actually. All right, based on this information, let's solve an equation. So let's find the zeros of a polynomial function. Okay, exercise 1, example 1. Okay, find all zeros of the polynomial and write the function, the polynomial, with the product of the leading coefficient and the linear factors. All right, so just like in the previous section, what we did is, in order to find, we need to find the real zeros, right? So let's find the P over Q. Okay, P is the factor of 16 and Q is the factor of the leading coefficient. In this case, the leading coefficient is 1, right? So it'll be plus or minus 2, plus or minus 1, starting with 1, and plus minus 2, plus minus 4, plus minus 8, plus minus 16 over 1, plus minus 1, right? So we can use, we can start from 1, -1, and so on to find a real solution. So if there's a real solution, then we can start from 1, right? All right, so from this, let's write the coefficient, use the synthetic division, whether to find the remainder 0. So when the remainder is 0, then the x value is the real 0. Okay, so starting from 1, because 1 is not working. 1 and -1 does not make the remainder 0. So let's start 2. You try 1 and -1. then you will see that the remainder is not 0. Okay, so let's try 2. I just want to save time. So let's try starting from 2. Then bring 1 down, multiply, and then add these 2, multiply, add, multiply, add, negative 8, and then multiply, negative 16. So the remainder is 0, right? So since 2 makes the remainder 0, 2 is a solution. Okay, and then also we may have a multiple zeros. Multiplicity is more than 1. So C may appear multiple times. So let's try this one. Divide this result by 2 again. So we never know, right? So we can try one more time. So if the remainder is 0, then 2 is another real 0. So bring 1 down, multiply 0, add it, then multiply 8. Look at this. So 2 is another 0, right? Another 0. All right, so we can rewrite it. P of x equals x minus 2 times x minus 2. And then finally, when we have 3 terms, then this is equal to x squared plus 0x plus 4 equals 0, right? So make this last line, 3 values in a quadratic form, quadratic equation. So make it 0, then what is x? Negative 4, right? So x equals plus or minus square root of negative 4. Finally, x equals, what is x? Plus or minus square root of 2i, right? Square root of 4i. Square root of 4i, because this negative sign becomes I. When it goes outside, it becomes I. So finally, x equals plus or minus 2i. So there are 2 more solutions. One is, this means x is 2i and x is negative 2i. So we can write a binomial factor like x minus 2i and then x plus 2i, right? Make sense? Okay, so that one gives you x minus 2i is equal to 0. This will give you x plus 2i is equal to 0, right? So this is a factor, another factor. All right, so finally, P of x can be written as x minus 2 squared, x minus 2, there are 2 of them, and the multiplicity is 2, right? And then you can write it x minus 2i, x plus 2i, like this. Even you can simplify more, but this one says write in its linear factors, right? So I just want to keep linear factors. Or if it's not linear factors, then you can write it as x minus 2 squared. What is this part? You can just write this one as it is, x squared plus 4. Still okay. But we were asked to write polynomial with linear factors like this. Make sense? So instead of writing this, write as a factor of, as a product of linear factors like this. Okay, then let's try letter B. Okay, the polynomial is now 2x to the 4th power plus x cubed. Now, when we write a factor polynomial, it's kind of it takes a lot of work because we need to use the synthetic division, and then try all the possible factors, rational factors. So it takes time actually. So P over Q, and then the possible real solutions are 70, factors of 70. There are so many, right? So plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6, and then plus or minus, is it, so what can divide 78? So 12, right? 13. So 13 and 26, right? That's more. And then 39 and 78. So plus or minus. There are so many, but you don't have to try all of them. And then divided by plus or minus 2, right? So it's a combination of this. So there are so many. So let's start from 1, negative 1, 1 half, negative 1 half, and so on. All right? So okay, let me cheat this. So from this, when x is negative 3, the remainder becomes 0. All right, so let's try negative 3. Okay, 2, 1, 39. Okay, use the synthetic division. Use the synthetic division. And then try, 1, negative 1, 2, negative 3, negative 2, positive 3, negative 3, and so on. So when you try negative 3, the remainder becomes 0. I get 2 down, and negative 6, negative 5, positive 15, 54, multiply 162, so add it, then 26, negative 26, then multiply by negative 3, so positive 78. So the remainder is 0, right? All right, and then also you can try negative to positive 1 half. Okay, 1 half, try 1 half. Then you will make the remainder 0. How do I know? Just try. Starting from, 1, negative 1, 1 half, and negative 1 half, and so on. So do it in order. All right, then 2 comes over here, multiply, then it's 1, so negative 4, multiply, negative 2, add it, 52. Then that will become positive 26, right? So bingo. So from here, you can write it like this. P of x equals x minus, so this means x equals negative 3 and x equals 1 over 2, right? So we have x plus 3 as one factor. Okay, before we do this, there's a leading coefficient. What's the leading coefficient? 2, right? So don't forget writing 2. No, you don't have to write 2, sorry. Wait a second. Yeah, we have to write 2 because 2 is the leading coefficient. So once you, factor out 2, we get something. So leading coefficient is, make sure to write the leading coefficient 2. And then from the first x value we got, which is negative 3, it becomes x plus 3, right? And then x is 1 half, so it will be x minus 1 half. And then the last line, 3, right? There are three numbers, that means x squared, right? 2x squared minus 4x plus 52, right? So from this, let's rewrite the last row in quadratic equation. Plus 52 equals 0. And then from here, we can divide the equation by 2 because the coefficients are positive. So x squared minus 2x plus 26 equals 0. So from this, we cannot factor this over the integer. So we can use a quadratic formula. What's the quadratic formula? Negative b plus or minus square root of b squared minus 4ac. Do you remember? Over 2a. So negative b, so negative times negative 2 plus or minus square root of b squared, negative 2 squared minus 4ac is 26 over 2a. All right. Then this is equal to 2 plus or minus square root of, 4 plus 104 is, minus 104 is negative 100 over 2. Then 2 plus or minus, is it square root of 100i, 100, right? 100i. So square root of 100 is 10. Can you see it? 10i over 2. So finally, x is 1 plus or minus 5i. All right. So we have two x values. So what are those two x values? So that means x is 1 plus 5i and the other one is 1 minus 5i. Right? So this one, so the first one will give you, x, move this one to the left. Then x minus 1 minus 5i equals 0. And from the second part, move this to the left and x minus 1 plus 5i equals 0. All right. So actually you can write the function like this, or you can rewrite it so that we want to write binomial factors, which is linear factors. So this part becomes x minus 1 minus 5i and x minus 1 plus 5i. Can you see it? All right, that's it. All right, there is a very useful definition, the conjugate pair theorem. That means, let's say a plus bi, bi, so let's say b is not 0. So this complex solution has two parts, real part and imaginary part, I, right, bi, because b is not 0. Then if this is a complex zero of a polynomial function, because the polynomial function has real coefficients only. Okay, real coefficients. The coefficients are real numbers. It does not contain the imaginary unit. All right, then the conjugate. The conjugate is a minus bi. Okay, one is the imaginary part is plus, right? Plus. Then the conjugate is the imaginary sign is opposite, minus. Then also the conjugate is a complex zero of the polynomial function. Really simple, right? So one complex solution is given, then always the conjugate of the solution is also a zero of the function. So find all zeros of this polynomial. Okay, example 2. Given that 2 plus I is a solution, right? It's a solution. It's a 0. So this means the conjugate which is 2 minus I is also a solution. Okay. Do you remember the irrational solutions? The quadratic formula gives you what? X equals plus or minus, right? Negative b plus or minus, right? Square root. So if the square root contains negative, then becomes imaginary solution. So there are always plus and minus. There are two of them. All right. So if the coefficient of the polynomial function is real numbers, then the conjugate is also a solution. So once a conjugate is given, let's find. We know that there are two of them, right? Two of them. The conjugate is also a solution. So we already found two solutions, right? So we need to find the other two. All right, so in order to do this, let's use the synthetic division, and then this time we're gonna give more space because we need to write the imaginary unit. Okay, imaginary unit. So let's put more space here. Then divide this by what? 2 plus I. Okay, let's start with 2 plus I. This one takes a little bit longer. And then the number 1 moves down and then multiply these two. There will be 2 plus I, right? So when we add two numbers, make sure you add the imaginary parts and add the real parts only. So the real parts are negative 4 and 2. So add negative 4 and 2. There will be negative 2 plus there's only one real part, so write it down. Okay, next, multiply these two. Then look at this. So 2 plus I times negative 2 plus I. Is it, can I just rewrite it? I plus 2, I minus 2, right? Then this is a plus b, a minus b. This is a difference square. So isn't it a squared minus b squared, right? So a squared is negative 1, b squared is negative 4. So that is negative 5. All right, so we can write negative 5. Add these two numbers, then there's 9. So multiply 9 and 2 plus I. So there will be negative 18 plus 9i, right? Add these two numbers. So there's positive 18, right? So add these two numbers, then negative 18 plus 9i. Then multiply two complex numbers. Right. Okay, so 2 plus I times negative 18 plus 9i. Okay, let's interchange the sides. So this time it will be much easier. And then factor out 9, right? Factor out 9 and interchange these two terms. So I minus 2, right? So isn't it difference of squares? Same thing as this one, right? Same thing as this one, right? So it will be 9 times I squared minus 2 squared. This is negative 1, negative 4, so negative 5. 9 times negative 5, so negative 45. So the result is negative 45. That's 0, right? 0. Okay, so since 2 plus I is a solution, 2 minus I is also a solution. So why don't we divide the result by 2 minus I as well? All right. Okay, so bring one down and multiply these two. So there will be 2 minus I. And then multiply these two. Add these two, then it becomes 0, right? 0. And then multiply 0 and 2 minus I is still 0. Add it, 9. And add these two numbers, complex number and 9. It's 18 minus 9i. And then add these two, it's 0. Bingo. And this third line has 3 parts. So we can rewrite it. X squared plus 9 is equal to 0. And then x squared equals negative 9. Okay, so x is plus or minus square root of negative 9. Then x is plus or minus square root of 9i. So finally, x is positive plus or minus 3i. Can you see it? So there are 2 more complex zeros. So therefore, the zeros are 2 plus I, 2 minus I, 3i, and negative 3i. Can you see it? All right. So what we did is we used synthetic division by dividing the polynomial by the given conjugate, given the solution, given 0, and then also used the conjugate of the given complex solution. All right. So when you multiply complex numbers, make sure you do the right step. Okay, do the right step. Okay, so when you multiply the conjugate, you can just use the distribution property. So I did again, so use the distribution property, and it's much easier to find the solution, to find the result, just like this. All right, the next equation, next example. Okay, find all zeros of the polynomial given that 3 minus 5i is a solution. So, okay, we know this is a solution, right? And the coefficients, all the coefficients are real numbers. So there's another one. This implies that the conjugate which is 3 plus 5i is also a solution, right? Solution. All right, let's find out. So use the synthetic division. Okay, so write the leading coefficients, or write the coefficients, and make sure give more space, because we want to write what? The imaginary part. Okay, so first we're going to divide this by 3 minus 5i, because 3 minus 5i is given, and once we divide it, we will divide the result by the conjugate, 3 plus 5i again. And bring one down, multiply, so 3 minus 5i, add it, so negative 7 minus 5i. Okay, multiply two conjugates. Okay, so this, use a scratch paper. I'm going to multiply these two. All right, so let's use distribution. 21 minus, this is 5i. So 15i minus 35i plus 25i squared. Then do 27 minus 50i. This is minus, I squared is equal to negative 1, right? So that's negative 25. Then finally it will be negative 52 minus 50i. Okay, let me double check. Okay, mistake. Three times 7, 21, right? And that is negative 15. And then multiply these two, 5 and 7. That is positive, right? Why is it negative? It's got to be positive. So negative 21, and then plus 20i minus 25. So add the real numbers. There will be 46, negative 46 plus 20i. Right, negative 46 plus 20i. So negative 46 goes here plus 20i. And add these two numbers, so it's 19 plus 20i. All right, so another product, complex numbers, right? 19 plus 20i. All right, so let's save time. Okay, let me try this first. All right, so once we multiply these two conjugates, it becomes 157 minus 35. So write it down in the next line, 157 minus 35i. All right, and add these two, so minus 27 minus 35i. Okay, let's try one more. So we're going to multiply 3 minus 5i and negative 27 minus 35i. Okay, so let me try it again. All right, so the product is negative 256 plus 30i. This kind of a tedious work, so let me write this one again. 256 plus 30i, and then the sum is 18 plus 30i, and then multiply these two. Okay, another scratch paper. We need to multiply two conjugates. So use a scratch paper to multiply these two. All right, so the result becomes only 204. So write down 204. Once we add the last column, it is 0. So the remainder is 0. Wow, it's pretty long, huh? All right, since 3 minus 5 is a solution, 3 plus 5i is also a solution. So we will do one more time. Divide the result by 3 plus 5i. So 1 goes down. All right, another multiplication, right? All right, so this time let's use a scratch paper here. Multiply 3 plus 5i this time. by negative 7 minus 5i. Okay, so it is not this one, not yet, not yet. It will be multiply these two, right? So it's gonna be 3 plus 5i. And once we add it, it becomes negative 4, right? Negative 4. Then multiply these two, then negative 12 minus 20i. Add these two complex numbers, then 7, and multiply 21 plus 35i. All the imaginary parts are gone, right? It's eliminated. So that's negative 6. Then multiply negative 18 plus, so negative 30i. And then finally, once we add each column, it becomes 0, right? It becomes 0. All right. So from this, we can rewrite it. Okay, there are 4 terms, which means this is a cube. Actually, this is a cube, right? X cubed, this minus 4x squared plus 7x minus 6. So setting this one 0, and then we need to find x. So P over Q equals what? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, over plus minus 1. So we will try each combination. All right. So let's try that one. Okay, so we can try starting 1, negative 1, and if they are not working, then we can try 2 and negative 2. So in this case, 2 is working, right? 2 is working. So why don't we divide this by 2? Okay, so before we do, okay, let me rewrite it. This part is what? X cubed minus 4x squared plus 7x minus 6 equals 0, right? So from here, P over Q equals plus or minus 1, plus or minus 2, 3, 6 over plus or minus 1. So that will be the combination of plus 1, plus 2, plus or minus 3, and plus or minus 6. So we will try each one of this. Then when x equals 2, let's see whether the remainder is 0. So bring one down, multiply, add, multiply, add, multiply 6. That is 0, right? All right, so from this, we can rewrite it, x squared minus 2x plus 3. So this should be equal to 0 so that we can find x. Can we factor it? It looks like we cannot find any integer factors, so let's use quadratic formula. The quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a, right? So negative b, so negative times negative 2 plus or minus square root of negative 2 squared minus 4, a is 1, c is 3 over 2a. All right, simplify. So 2 plus or minus square root of, 4 minus 12. So 4 minus 12 is negative 8 over 2. Then this is equal to, 2 plus or minus square root of 8i, right? 8i over 2. Then 2 plus or minus, 8 is 4 times 2. So 2 square root of 2i over 2. So finally, we can write it 1 plus or minus square root of 2i. So these are the two solutions. So how many solutions are there? So the zeros are, so therefore the zeros are, now 3 minus 5. This is given. So the conjugate is also a solution. And then we got 2, right? 2. And there are two more complex solutions. One is 1 plus 2 square root of 2i. The other one is the conjugate, 1 minus square root of 2i. All right, so there are how many of them? There are 5 zeros. Can you see it? What is the degree? The degree is 5, right? So including the conjugate solution, conjugate zeros, there are 5 of them altogether. Okay, now solve this polynomial equation. Okay, the degree is 4. So if there are complex solutions, then there are at most, and exactly 4 complex solutions. Exactly 4, right? If we include the complex solution. So anyway, let's find the possible real zeros. So P over Q. So P over Q is plus or minus 1, plus or minus 3, plus or minus 9 over 1, right? Over 1. So we can use one of this. And then let's use the synthetic division. And then let's find whether these numbers make the remainder 0. So starting from 1, 2, negative 1, okay, 1, negative 1, 3, negative 9, and negative 3, and so on. Okay, 1 does not make the remainder 0. Also, negative 1 does not make the remainder 0. So why don't we try 3? We want to save time, so let's try 3, then bring 1 down. And then 3 times 1 is 3, add it, multiply, add, multiply, add, multiply, negative 9. That is 0, right? 0. So we found one solution, x equals 3. So let's find another one. 1 does not work, negative 1 does not work, 3 worked. So we may have another 3. So we never know, right? So we can try 3 again. So 1 down, 3 times 1 is 3, add, multiply, add, multiply. That's 0, right? So there are 2 solutions. So x equals 3, right? Here's another x equals 3. And then using this one, let's write x squared plus x plus 1 equals 0. Then from this, we can factor this one over integer, so we can use what? Quadratic formula. The quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. So negative 1 plus or minus 1 squared minus 4 times 1 times 1 over 2 times 1. Then negative 1 plus or minus square root of 1 minus 4 is 3, so negative 3 over 2. So we can rewrite it, negative 1 plus or minus square root of 3i over 2. So negative 1 over 2 plus or minus square root of 3 over 2i. All right, so we found other 2 solutions. So the solutions are 3, 3. So there are 2 3's, right? Multiplicity is 3. And then 2 complex solutions. One is negative 1 over 2 plus square root of 3 over 2i. And another one is negative 1 half minus square root of 3 over 2i. Okay. All right, let's find polynomial function this time. So the polynomial function has a degree 3, so n is 3, right? And zeros there are 3 zeros. All right, so x equals 1, x equals 2, and x equals negative 3, right? So if we move 1 to the other side, then x minus 1 is a factor from here, and from here, x minus 2 is a factor. That equals 0, right? That is equal to 0. So from here, x minus 3 is equal to 0. So we can write a function, and this function is product of these 3 binomial factors. So x minus 1. What we do is that we just go in reverse order, reverse. So if a polynomial is given, then from this polynomial, we factored it, and then we set each factor equal to 0, right? So that we found the real zeros in this case. But, this time real zeros are given. So from the given x value, we go in reverse order. All right. So that's it, right? That's it. So that if we simplify this, then x minus 1, so multiply these 2, that will be x squared minus 5x plus 6, right? Then multiply x, it's, use the distribution property again, so x cubed minus 5x squared plus 6x, then minus x squared plus 5x. What you do is just rewrite it. So x cubed minus 6x squared plus 11x minus 6. Is there something is wrong? Okay, let me double check. Okay, I'm sorry. Okay, when this negative 3 goes to the left, it's positive 3, right? Positive 3. So this is plus 3. So we have the wrong number. So it's got to be x minus 2 times x plus 3. There you go. So let me solve this to save time. All right, so when we simplify this product of 3 binomial factors, it comes up like this. So that is the polynomial function that satisfies this information. Okay, the next one. Okay, the next one is there are negative 2i is given. The real zeros are negative 2i. So we know that the conjugate 2i is also a 0, and then 3 plus 7i is a 0. So we know that 3 minus 7i is a 0. So the polynomial function is there are 4 factors, right? So x minus 2i, so there will be plus 2i, and then x minus 2i, right? And then x minus 3 plus 7i, right? All right. Okay, let me use a bracket. And then another one. So x minus 3 minus 7i. All right. Then let's use distribution property and then spread everything. So the first one. So x times x, this will take a lot of time. So x squared, this is a squared minus b squared, right? So x squared minus 2i squared. So it will be x squared plus 4, right? 4, okay, later. Okay, and then inside this one, okay, multiply this, so it will be x squared, multiply these two, so minus x times 3 minus 7i, right? And then multiply these two, so minus x times 3 plus 7i, and then finally these two, so it will be plus 3 plus 7i, 3 minus 7i. This takes a lot of time. And then, okay, sorry, there's no squared, right? No squared. This squared, right? This squared. So x squared plus minus 4i squared. And this I squared become negative 1, right? This is negative 1. Okay, so that will be, so let me write this factor first, plus 4. All right, then let's simplify this bracket. So x squared minus 3x plus 7xi. Okay, so plus 3x minus 7xi plus, isn't this a squared minus b squared, right? Difference of squares. So 3 squared is 9, minus 7 times 7 is 49, right? 49. I squared. All right, so that is x squared, and then 3x minus 3x cancel out, 7xi minus 7xi cancel out, so we have 9, then minus 49, I squared is equal to negative 1, right? Negative 1, so it will be plus 49. So x squared plus 4, and then finally x squared plus 58. Oh, did we miss anything? I think I missed something. Okay, let me check. All right, there is a mistake. So when you multiply these two, it's a negative 3x, right? Negative 3x. So that is negative 3x, the minus 7xi. All right, so negative 3x is negative 6x. Negative 6x. So plus 9 plus 49. So negative 6x plus 58. Okay, finally, let's try one more distribution. It's a lot of work, right? So let me try this to save time. All right, so there are two more lines. So once we distribute and simplify, okay, this is the polynomial. Wow, it takes really took our time, right? All right, so once the zeros are given, then we can write a product of what? Binomials, right? X minus something. All right, and then use the distribution property to rewrite the polynomial. All right, that's it for this section. And I hope, this is really complicated section. It's too much work, right? All right, then try some exercise.